with that, listeners, welcome to the Cloud Security Podcast by Google. Thanks for joining us today. Your host here is just myself today, Tim Peacock, a group PM in Google SecOps. If you want to subscribe to the show, you can follow us on YouTube, youtube.com/@CloudSecPodcast. Hosting by myself today, so no fun banter. Delighted to go straight into introducing today's guest. Today, we are joined by Doug Turner, Director of Engineering on Google Chrome, and Jasika Bawa, somebody I've wanted to work with for years. Never really had the chance to, but we've always been friends in Google Cloud. She's the product lead for Chrome security, which is what a cool job. I wish I had that job. So, Doug, I want to talk about the blog post that just came out. It says your Gemini agent harness found a 13-year-old sandbox escape in Google Chrome. And now that bug is almost as old as your children, as we just established. So tell us, how did this bug lurk in the code base for so long?
I know, that's a really good question. And, it's kind of amazing to see what AI can find. I mean, it's humbling because, for 13 years, people have walked over that code base and not seen it. And it does remind me of Anthropic's post about Mythos finding a similar bug, like a 20-year-old bug in OpenBSD, which is something we have to learn from. And, I looked at the 13-year-old bug recently of what actually happened. And it's kind of a classic problem where it's a very, specific logic bug where you have disjoint systems, one assuming that the other will validate, and it didn't. And so in this bug, we have the browser trying to look at file permissions, and then we have the HTTP stack, looking at a post message to make sure. And in our code base, these are very, very disjoint parts of the system. And so, when you kind of think about it, the classic problem, A assumes B is doing something, B doesn't do that. It's very hard for a person to see that. It's even hard for classic fuzzing techniques to see this because you need to have a certain large sequence of events to happen to facilitate that type of vulnerability. Now, what I'm really excited about is humans didn't find this bug. Our Gemini vulnerability scanning harness found it. And it didn't just find the bug and point it out. It ended up building a proof of concept so that a human developer can say, oh yeah, that is a bug and I can see how it works. And, we don't even build a suggested fix so that the developer could reason about the vulnerability, see how it actually can be accomplished, and then have, at least at a starting point of a fix for that particular vulnerability. So overall, I'm really excited about this space because, it's, these models are allowing us to see well past what the human capabilities are so that we can find these underlying security bugs and fix them very, very, very quickly.
Let me dig in on that for a sec, because I think you said something interesting there about the contrast with fuzzing, where you would require kind of this combinatoric luck to stumble upon these two things interacting.
Right.
How did Gemini figure out that these two things might interact in a way that violated our assumptions?
Yeah, that's the maybe multi-billion-dollar question. So these models have a brain and they have a set of reasons, but it's very hard to know how it is reasoning about these. So in classic fuzzing, what you would say is, okay, here's an API, here's how generally it's supposed to be used. And as you mentioned, we run hundreds of thousands of permutations against that API on that. And so we still do that. It's still very, very important, especially on some of our language features. We do that all the time. But on these, multi-step kind of problems, these models seem to be able to reason much better than the average software developer, as illustrated on this 13-year-old vulnerability.
I think we have well above the average software engineer working on Chrome, I would hope.
Heck yes, we do. Yeah.
So I want to talk about the fix then, because you mentioned that Gemini suggested a fix, and more broadly than this one 13-year-old bug, Chrome 149 and 150 fixed over 1,000 security bugs, which is more than the last 23 releases combined.
Yes.
First off, that's a lot of fixes.
Right.
How is that possible? How did you do this?
Yeah, I mean, this is something I'm very proud of and proud of the team of. And so what we've built is a pipeline from vulnerability discovery. So we have, advanced models looking at the software, trying to find the vulnerabilities, as I mentioned before. And then what we have is, an agent that tries to build a proof of concept so that we can verify that it's a real bug. We have an agent that tries to determine the severity of the bug. So is this really, really bad that we should stop everything and work on? Or is this an S2 that we can get to it, in a few months? And then we have a system that builds a suggested fix and even an agent that will find a human developer to take on the work and actually land the code to fix the vulnerability. So, you can do this at scale when you have these pipelines in place so that you can go from autonomous, automatic, vulnerability scanner all the way down to something that can give a developer a suggested fix. And so you basically do that at scale.
That's amazing. And so it is still a developer agreeing to the fix at the end of the day. It's not just two robots, grading each other on a scale and saying, yes, robot, you're awesome. No, robot, you're awesome.
No, it's not token maxing or something like that. So in fact, in Chrome, it still takes two developers. So the suggested fix goes to developer A, and they have to read it, completely understand it, and, basically assert that, yes, this is a fix that I am comfortable with. And then they hand it to a second Chromium developer, and that person has to review the changes. So we still have, the same type of engineering rigor, no matter if it came from this automated pipeline or if it came from any other patch or CL that happened, a year or two ago.
Oh, that's good. So we're not totally vibe coding Chrome at this point.
No, there's no vibe coding. No.
Okay, good. I like that. I like hearing that. That makes me happy since we're doing this meeting on Chrome and literally everything I do is via Chrome.
Thank you.
Jasika, I want to talk about pushing updates. So you own Chrome from the product standpoint. Pushing updates used to be a pretty big thing, and now you're pushing multiple security releases a week. Is this like developer burnout? Are you going to make IT admins really sad? How are you balancing stability with security? How are you developing the right intuition for that, the right framework for that? What does that look like for a PM?
Yeah, good question. And yes, we have been pushing 2 security releases per week since about June timeframe. And I think it's important to start by establishing, why are we in this situation? The threat landscape has shifted. So attackers have always worked very quickly to reverse engineer security bug fixes the moment they land, right? This is not new. I remember back when I worked at Microsoft, there was this tradition of Exploit Wednesday that used to follow our Patch Tuesday cadence.
Tuesday, Exploit Wednesday.
Exactly. Yeah. The natural order of things. So this aspect is not new. But now with AI tools, the actual reverse engineering of the bug fix is much easier than it has been before. So it can be done with less tedium, less manual work on the part of an attacker.
So Exploit Tuesday afternoon, not Exploit Wednesday.
Yeah. Exploit Tuesday after lunch. Exactly. Yeah. So I think the other thing is that we also have good reason to believe that AI tooling is going to make it easier for attackers to chain bugs together into functioning exploits, right? Again, previously a task that attackers were doing, but pretty tedious and manual. So the threat landscape has fundamentally shifted and we need to be able to respond. But, we haven't just doubled the release cadence and asked the engineering teams to work double shifts. So Doug talked a little bit about how we're using AI to generate candidate fixes for bugs and sort of trying to evolve an engineer's role towards more of review and approve than, again, manual bug fixing. Another example I can provide is we've been using AI and automation to help generate release notes and CVE descriptions. Again, previously pretty manual process. So we're really trying to look holistically across the security bug lifecycle and use AI and automation tooling to our advantage to really remove operational friction as much as possible and kind of avoid this developer burnout issue that you mentioned.
And what are you doing for the enterprise IT admin who's now getting updates to their software twice a week?
Yeah, fun times for them. They've always been very important in their organizations and they will continue to be very important and if not more in this brave new world that we're in. So we have a bunch of options, I would say, for an enterprise IT admin to choose depending on their organization's needs and risk tolerance. So for one, we have dashboards, Tim. We've got dashboards galore.
We've got dashboards.
Yeah, we've got them through the Chrome Enterprise Core and the Chrome Enterprise Premium offerings, really to provide IT admins with visibility into browser versions across their fleet. So this is OS agnostic because we understand that, there's not such any homogeneity anymore in operating systems, and also to offer IT admins granular controls around how to control the updates. So that's important. I think visibility is very important, and also related to this visibility topic, I mentioned about release notes and CVE descriptions. We really try to be very verbose with, what are these security bug fixes that are going into these releases. A second one, which you and Doug are probably very familiar with because we use it internally at Google, is that we offer an enterprise policy that sort of prompts end users to restart Chrome when a security update is available, right?
Somehow it always restarts Chrome when I'm in the middle of something important.
I was going to ask, has it ever happened in one of your podcast recordings?
No, it never has. Actually, 290 episodes, it has never restarted Chrome during a podcast. And I feel like I need to knock on wood and not get kicked out right now.
It's the age of the phone apocalypse, Tim. It might happen at this point, but no. So yeah, we have this enterprise policy. Again, we use it internally, starts with a gentle nudge and sort of escalates over a set amount of time until at the end of the day, a forced restart. And then finally, for organizations that are very sensitive environments, or maybe there's some regulatory need to vet every single release before, deploying it across your fleet, we also offer the Chrome Extended Stable channel. This actually stays on a major milestone for 8 weeks.
Oh, wow.
Normally, we have a 2-week feature release cadence, so major milestones increment every 2 weeks. But this one will stay sort of feature frozen for 8 weeks. It still receives security updates because we don't want to leave it vulnerable, but the feature set remains locked and stable.
Nice.
But, after discussing all this, I just want to mention that this is not the long-term goal, right? The long-term goal for us is a Chrome that is continuously and dynamically patched and restarted automatically for users during opportune moments.
Okay, so let's talk about that, because that was one of the things that really blew me away when I read the blog post. I read that, listeners, this is so funny. Jessica and I have talked about doing a show together for ages, and I happened to see this blog post about the Chrome stuff, and I'll link in the show notes, on LinkedIn a couple mornings ago. And not moments later, Jessica pings me and says, "Hey, we're doing this stuff. Can we come on the show and talk about it?" And so it was the perfect timing for this to all come together. But one of the things that blew me away in the blog post, and maybe, Doug, you want to talk about this as well, is this dynamic patching thing. I'm looking at my screen. I've probably got 50 tabs open right now. And every time I restart Chrome, I have this fear that everything in my head / in my Chrome is just going into the proverbial woodchipper. But now you've got a background tab process restart? What the heck did you invent, and how does it work? Because that sounds amazing.
I will take this one, Doug, if you don't mind, because I'm driving the Patch Gap product strategy. But yeah, please feel free to jump in. First of all, Tim, I just want to address your anxiety about tabs, right? This is real. I'm here to validate your feelings.
Yeah.
This is real anxiety. And I would also just postulate, worrying about tabs is actually quite a normal thing. I do much weirder things in Chrome that cause me anxiety. So here's a particularly unhinged behavior. Sometimes if someone tells me something really quick and I need to take a quick note, I open a new tab and I write this thing in the Omnibox and I simply leave it there.
You use the Omnibar as a notepad?
Sometimes. And I'm I'll get to it later and move it to a more proper location. But so I'm just saying tabs is a normal thing to worry about. Okay. So
that is unhinged.
Yeah. Just to reassure you there. Look, I really want to emphasize the core problem which you identified, which is no one wants to restart Chrome. I had this whole existential rant to my team last year at some point where I was I think it's so unfair that the AI gets to write poetry now, and I'm stuck just touching YubiKeys and restarting Chrome all day. It feels very unfair, I want to do the fun things that the AI is doing. So look, I mentioned a bit at the end, of the previous section, our goal is you should not have to restart Chrome yourself. This is where we are today, but this is not where we want to be longer term. So I want to talk about two aspects of the product strategy. One is restarting Chrome on your behalf during opportune moments. And then I also want to talk about the dynamic patching, and Doug might have more cool engineering tidbits to throw in here. So yeah, we want to invest in restarting Chrome when it is least disruptive to you and when we feel quite confident that we can fully restore your session. Okay, so least disruptive. Let's talk about this first. What does least disruptive mean? We can use an example from one of our recent launches where we said for Chrome on Mac, if you have no windows open, we'll just restart Chrome. That's very less disruptive. You literally didn't have anything open, right? Another example could be your machine is locked. So you're obviously not using Chrome. Maybe that's not a disruptive moment. Another example could be you scheduled the restart yourself. So, hopefully that was not a disruptive moment for you. So these are kind of examples of like what like least disruptive might look like. And then I want to also talk about like session restore, because this is, I mean, you know, you're asking kind of like, how are we making product decisions in this space? Like, this is a pretty tricky one because we really want to balance, obviously, the importance. I mean, I'm a security PM at the end of the day. So, you know, the importance of like getting these updates out there and having users restart, but with also like causing as less disruption to the user as possible. So, you know, your tabs, for one, I would say, don't worry about these. Like, your tabs will reopen. This is the most important thing.
They mostly come back these days. I haven't lost my tabs in a long time.
Exactly. So you should not lose tabs. Like, this is not even a thing we should be worrying about. But even beyond tabs, we're thinking about other more complex cases of like losing state, right? So one example that my team is thinking about right now is unsubmitted form fields. You know, maybe you spend a bunch of time filling out a long form and, you know, it's not submitted. Like, how do we think about saving state in that case? Or
I had that happen to me the other day.
So these are currently like kind of edge cases that we have to think very critically about. And I'm convinced that we can do better in terms of, engineering solutions. Doug and his team are all over it. Another example is like, and this one is pretty dear to me, like, let's say you're reading like your 400 and something page PDF of the Odyssey.
Normal.
And you don't remember what part. Yeah, what page are you on? Like, so these are kind of like, we're really thinking very deeply about cases like this. So not just tabs. Like, I think tabs is table stakes. Like, you should expect tabs from us. That's not a negotiable, but we're thinking even farther than that about restoring state as best as possible. And then where it's not technically feasible, then we have to make these difficult trade-off decisions about like, okay, in this case, we would prioritize security and maybe there's some work loss, but the goal is to avoid that altogether. But then you also mentioned our early foray into the exciting world of dynamic patching.
Yeah.
Yeah. So I think, you know, it seems like such a risky proposition, right? But like the way the Eng team has sort of like thought about this from an architectural perspective, like I'm fully convinced like this is going to work. So again, Doug and his team really need to make it happen. But kind of the way they have set out this plan, like from a technical perspective is, let's say you have a tab open and, you know, you're recording this podcast or whatever. If like a security patch lands on your machine, we don't kill the renderer process that is running this tab. We leave it be. We put like sort of a freeze on it to say like, don't reuse this renderer process at this point, but, you know, continue to do whatever's happening in this tab. So until that tab is closed by you or you perform a new navigation within that tab, there's no disruption at all and you're using the old renderer process. The minute you open a new tab or you perform a new navigation within that old tab, Chrome's process manager will sort of point that new request to the new patched binary. So really what happens is like over the course of your browsing, the old processes sort of like get dynamically flushed out, the vulnerable ones, and they get automatically replaced by the patched ones. It should be quite seamless, actually, to a user.
That's really cool.
And I think it's honestly like such a cool like architectural solution, that the Eng team is coming up with.
Can I ask a dumb question? Like, why didn't we do that sooner? That seems so intuitive when you explain it that way. Why is it 2026 and we're doing that, not 2016 or 2012 we're doing that?
Doug, what do you think?
I mean, this is like a pretty hard problem, not only from, you know, the logistics. I mean, the logistics are the hard part of this problem. So like what Jasika explained is right. So Chrome is a constellation of processes. Tabs are, you know, a tab is associated with a process, a rendering process. We have these ideas of site isolation so that like certain origins are forced to be in certain renderers. And so we can make these, you know, from a technical point of view, we can create a new renderer and have it run basically a different binary. So we can patch it. And the next time you launch the renderer, you'll get the safe version or the safer version with all the new vulnerability patches. Now, we also have to generate these patches on the back end, right? And so, you know, from, you know, the operational point of view, okay, it's not just shipping twice a week. It's like we have to spin something up like every day and we have to deploy this in a safe way. And, you know, if you look back, well, Jasika mentioned the entire landscape of security has changed with the rise of, you know, vulnerabilities being found by LLMs. So we need to close this patch gap. And we didn't have to worry about it like 2 years ago. It was a simpler time where, you know, now what we're seeing is, the time it takes to go from a vulnerability being patched in an open source project to the time it's being exploited used to be, like if you go back to 2018, it might be months. Now we're in the hours. And so there's a massive sense of urgency to close this patch gap. And, generally that's why we didn't see a need for it 2 years ago. And so, yeah, and also like Jasika explained it perfectly. I'll accept her CLs as soon as she gets back to her desk and starts, cranking on those, Gemini CLs for us. So
it is very technically complex. Like I think that's like one of the it's a really hard problem, but I'm excited for our team to pull it off.
It's a hard problem. And it sounds like this is one of those like necessity is the mother of invention things here, where 2 years ago we didn't need this breakneck pace and now we truly do. So I appreciate that. I think that's a super reasonable answer. I want to talk about another one of the interesting technical things in the blog post, which was the spanification effort and the work that you're doing with Rust. So could you tell us about what's going on there? And is this is really timely because this week's episode, when we're recording this on August 5th, this week's episode of the show is actually about eliminating classes of vulnerability at Google. So it sounds like you're engaged in that process once again, which is really exciting.
Yeah, that's right, Tim. And so, if you look at what we have, Chromium is composed of, anywhere between 35 and 50 million lines of code. And the majority of it is C++. And the majority of it will remain C++ for a while. Okay. And so we must do something to, alleviate classes of bugs that developers face every single day. And, we had a project a few months ago called a Miracle Pointer. And this is a protection against dangling pointers. So in C++, if you delete a pointer and go to reuse it, you might have a really bad time. It's a source of a lot of vulnerabilities. And so with something called Miracle Pointer, it's a smart pointer. So when things get deleted, you can't reuse that pointer, right? It'll crash, which is what you would expect to have happen in, a modern software system. Spanification is a similar project where, a lot of times in large software systems, you'll pass around a pointer and its length. And, the recipient of that pointer and that length should not address the pointer past the length.
You would hope.
But this happens and, people make mistakes. And so spanification is an effort to rid us of that class of vulnerabilities. Now both of these two things, Miracle Pointer and spanification, have runtime costs, right? Because the compiler is going to generate instructions to say, before you do this, check that. And so these things come at a cost to Chrome. And, we have a systems problem where we want these things and we have to find ways to pay for their performance. So we have a performance team essentially covering the cost of these runtime performance with other optimizations. So from the user's point of view, they're just going to get a more secure version of Chrome. Now, the long game, though, is likely Rust. And so we have two paths here. So the leaf nodes of Chrome, these are things that are not intertangled in the rest of Chromium. These are things like image codecs or our font library. These things are leaf nodes and they should be written in Rust. There's no reason not to. There's strict APIs or ABIs that we can use, and we are doing that. And, a class of bugs is not so much the decoding of an image, but the parsing of metadata, which is usually very scary. FreeType is a font library. It's an ancient library. I think it was made for OS2. It was ported to Pascal and then back to C. It's been a source.
You're scaring me.
Oh, yeah. I mean, I think David Turner wrote the first version of FreeType back in the day. No relation, but it's been a source of a lot of use after Freeze. And we have been rewriting that from the ground up in a library called Fontations, which is all Rust. So, we want these things in the leaf nodes as fast as we can take them, as long as they're, as capable as the former version and don't have huge performance penalties. And we're not seeing that. The second thing we're doing with Rust is you can kind of think about it like a Chromium SDK. If you were going to write something in the middle of Chrome or in the middle of Chromium, you might need access to things that are like our metrics logging system, or how to post a task to a different thread, or, what's the user's profile name? These are things that C++ can give you right now. If you write in C++, you have access to all this. But if you write in Rust, you don't. And that is a challenge. And so, we have another effort, making sure that the Chromium developer using the Rust programming language will have a good time as they build their features in the middle of Chromium.
Okay, very cool. I love both the consideration of the need as well as the performance optimization. So we're not paying for the the spans, the miracle pointers with billions of slower laptops.
Right, exactly.
I want to ask a question that will get me credit with my old boss, Alan Friedman. You've got 2,300 third-party dependencies. How are you possibly managing your supply chain security for Chrome?
First, 2,300 open source, dependencies is kind of incredible just to think about it, right? You download Chrome and it comes with like an ecosystem of lots of open source developers contributing.
An ecosystem, like a whole continental scale biome of things.
100%. And so some of these libraries are really well taken care of. So if you think of things like, V8, which is, our JavaScript library, it's super fast, super awesome. It's well maintained. It's one of these 2,300. Skia, 2D library, Angle.
You count V8 as a third-party dependency? I thought we built that for Chrome.
Yeah, it is a separate open source project. Huh. And so it's used all over the place. So I'm pretty sure it's used in Node and a whole bunch of cloud services. You look at Skia, which is our 2D library, also built with a lot of Google engineers. Open source. We have open source contributions to it. It's used basically in everything. And so if you do 2D graphics, generally you're using, Skia. You might use other libraries like Cairo, but Skia is one of the better ones. So, but you have these really well-known canonical kind of open source projects that are well maintained and awesome. And then you have the 2,300 others, right? And so it's a rounding error. And so, what we have to do is make sure that every one of these libraries is safe to incorporate. And so we have an automated pipeline that looks at every software library that we ingest. And, the white paper that we're talking about does describe this. Internally to Google, we have a system called Gossip. That's an acronym.
Yeah. What's Gossip? Spill the tea on Gossip.
Yeah. So, I love acronyms, right? And, people can never remember acronyms for what I think it's for the Google open source. I don't remember, a Google open source intelligence platform or something like this.
Sure, close enough.
Regardless of the name, it provides us a signal of kind of safety or quality for all the libraries we ingest. So, it certainly looks at things like CVEs. Have there been any recent CVEs that have been reported, and are they fixed in that particular library? They look at other public data sets, like there's an open source vulnerability database that it looks at. It also looks at things that are has the domain name registry changed, which is, one of the more classic attacks. It also looks at, does it look like it's an active project or has it been abandoned? And so this entire system is built into the process that we use to ingest updates to these 2,300 libraries.
Amazing. Okay. So I hate to do it because I think we could talk about Chrome security all day, and I would like to personally, but as I shared before the episode, I have some important things to go do. Traditional closing questions. One, do you have a piece of advice to help people who are managing gigantic open source projects like this be more secure? And then two, do you have recommended reading? And that recommended reading could be literally anything except Anton's blog.
Well, I'll take the first question probably. So it might be preaching to the choir of the software engineers that are listening. So I've worked in large open source projects for probably 30 years, starting at Netscape.
Wow.
I was there when Jim Barksdale open sourced Mozilla. They brought basically a wagon wheel of all the printed they printed out all the software on paper and put it in front of us as now it's available to everybody. And then, I've worked at Mozilla for over a decade and now on Chrome for almost a decade. And, the key thing about these things is the people that you employ and the ethos and the culture have to recognize that the software, the code is actually a product to itself. So you have to have the same energy and the same care that you do with the end user product, the feature, the UI, everything that shows up in release notes, as you do with how well the code is written, what C++ language they're using, what compilers, the architecture, the internal toolings, all of that matters just as much in these large open source projects. And keep in mind, typically you have thousands of developers working on this. It becomes, your downstreams are really important and those customers are really important. So you have to take this really high, ethos when you're talking about open source code. And I do think that's kind of the philosophy in Chromium. I've been working on it for, 10 years for Google and a little bit before. And we set an incredibly high bar for our software, our code. And I think it shows up because like in my experience, tech debt becomes, security debt in some places. And
very quickly.
Maybe that can be seen with some of the security bugs that we have discovered. But I think that's really the most important thing. Like you have to treat the code as a product that you ship.
Doug, I love that answer. And it's crazy to me that you've been shipping browser code for almost as long as I've been alive.
Tim, I don't know how I should feel about that. It goes by fast. And so like, I know we spoke about it before, but make sure you make a lot of memories because the time does go by fast. And I've loved every minute. Like building browsers is like one of the best things I could have done in my career for sure.
Well, let me express my gratitude because I used every one of the browsers you named and I have memories of using each browser and what that era for me of exploring the internet was like. And yeah, wild.
Very cool.
Jasika, do you want to take the reading question?
I do. I also just really liked kind of how Doug said that the code base is like a product. I quite like it. Tim, I think it bodes well for PMs of the flavor of you and I.
Yeah, it does.
That like to treat the code base as a product, like I really like that way of thinking. I think, yeah, overall, I would say like there's a few things that are top of mind and I will answer your reading question, but I don't think you would like it. I feel that as we are sort of entering what I'm considering the normalized phase of the Bone Apocalypse, like we've been in this kind of for about over 6 months now. I'm thinking a lot about like operationalizing and scaling the work that we're doing. So a couple of like concrete things that my team and I are thinking about. One, I think it's really, really important that we defend against the introduction of new security bugs into the code base, both as we're fixing security bugs and as we're introducing new features. So I think this is something really important for all of us to be focusing on. On Chrome, we're doing this by moving more security checks into the commit queue. So, static analysis, flagging things like unsafe buffer usage, dangling pointers, memory safety issues, all our favorites, before code ever lands really in the main tree. I think this is like really important, right? I'm again thinking about the operationalization of this whole thing. Like we don't want to be in an endless hamster wheel.
Yeah.
It's like, we can't be doing what we've been doing.
No, I love making that point about our industry that, if you compare, say, software security to aviation safety, we're really bad at our jobs. Planes basically never crash and software is basically always broken.
Yeah. I had this feeling the one time I toured a data center. I was like, wow, the hardware guys really have their act together. And us software people, we're just all over the place. We're like, we'll just ship it and fix it later. But yeah, so I think like for one, really shouldn't be introducing more bugs. The second piece, we talked about it, like Doug walked us through kind of our strategy around Rust and C++ mitigations, but we really, really need to maintain our long-term focus on eliminating entire classes of bugs. Like I really cannot emphasize this enough. Like simply fixing bugs forever is not a sustainable strategy.
Yeah.
And so we cannot allow ourselves to be distracted in this moment of like, high drama, high stress, like, oh, there's all these bugs, like, we've got to fix them and they have SLOs and that's all like, very good reasons. But we need to also maintain our focus on kind of, eliminating classes of bugs, like really important. And the third thing is like a bit PME, but I'm really thinking of like our engineering teams as customers. In this Bone Apocalypse age, like what are their pain points? Like there are several, let me put it that way.
Yeah, several.
Yeah, so I really, my team and I are really thinking about like what are the pain points of like the engineering teams and how can we use the tooling that we have at our disposal or build new tooling to kind of alleviate these pain points, again, across the entire bug lifecycle. Again, thinking about like getting into a sustainable state of operations with this new like AI can find security bugs era that we're in. So for reading,
yeah, please.
Look, I figured like because it's a security podcast, I want to recommend that folks would read the blog that we published last week. As you mentioned earlier, it's stronger with every update. I think it would be so cool if everyone could give it a read. It really represents the work of a very passionate team, and it's kind of an honor to be able to tell the story of what the past, 6 months or so have been like in the trenches of the Bone Apocalypse here on Chrome. But if you were looking for more like non-security related reading,
could be anything. I think that's a great recommendation. I feel honored to help you guys tell the story today. So this is great to be a part of the story.
I think everyone should read The Count of Monte Cristo.
Okay.
Unrelated to the Bone Apocalypse, but yeah, it's an important study on human characters.
Nice. Well, Doug, Jasika, thank you so much for joining me today. I love Chrome. I have used it since 2008, and I've always really admired the team that puts it together. So it's really an honor to get to speak with you guys today and host you on the show. So thank you.
Thank you very much, Tim.
Thanks for having us.
And now we are at time. Thank you very much for listening and, of course, for subscribing. Please subscribe so you can get new episodes piping hot. And if you love our content, please drop us a review on your platform of choice.
You can find this podcast on YouTube, Apple Podcasts, Spotify, or wherever you get your podcasts. Also, you can find us on our website, cloud.withgoogle.com/cloud-security/podcasts. You can argue with us on the Google Cloud Security Community site, googlecloudcommunity.com.
You can follow us on x.com/cloudsecpodcast, tweet at us, email us, argue with us, and if we like or hate what we hear, we can invite you to the next episode.
See you on the next episode of the Cloud Security Podcast by Google.